In this lesson, we're going to talk about how to write quadratic functions. By the end of this lesson, you should be able to write quadratic functions in vertex form and in standard form, and then you should also be able to convert from vertex to standard form. When we're writing an equation in standard form, one of the ways that we can write it is by using its roots. So we identify the two zeros, root 1 or root 2, and we need another point on the graph so that we can figure out what a is. You're going to write it as the linear factors, so it's the opposite of the roots. So if my roots were -3 and +6, my factors would be x plus 3, x minus 6. That would be the way that we would get them to solve. Then I would factor the binomials and then distribute out a. But we would have to solve for a by using another point in the equation first. When we're writing in vertex form, we're going to substitute in the values for h and k. Remember that h does not include the negative sign. So if you plug in a negative value, it's going to change it from -h to +h. Substitute in another point, again, x and y, so that we can solve for a. And they're going to rewrite the equation with a, h, and k. When we're changing, when we're writing, again, writing from standard form, you're going to identify the zeros in a point, determine the factors, write the equation. In vertex form, identify the vertex, choose a point, solve for a, write the equation. All right. Number 1. We're looking at writing this equation in standard form. I know that my solutions are 4 and -7. So I'm going to write this in root form. So again, root form would be y equals a x minus r1, x minus r2. Again, could be, depending on what your root is, the sign in there is going to change. So I'm going to start off with my roots. Y equals a. Because this is +4, it's going to be x minus 4. Because the root is -7, it's going to be x plus 7. Again, that has to do with when I go back and solve it. If I solve x minus 4, I get +4. If I were to solve x plus 7, I would get -7. So you're writing the roots the opposite. You're writing the factors the opposite of the root. Now I need to figure out what a is. We still don't know what this value is, if it's 1 or if it's another number. So to solve for it, we take a point that's on the graph. So here my point is 5, 12. And I substitute those in for x and y. So my y is 12. My x is 5. I solve for a. 12 equals a times 1 times 12. I get 12 is equal to 12a. Because 1 times 12 is 12, times a is 12a. Divide both sides by 12. I get a is equal to 1. So I know that a is equal to 1 in this case. Once I have that piece, I'm going to rewrite it. So y equals 1, x minus 4, x plus 7. Then I FOIL and distribute the 1. When I FOIL, I get x squared plus 7x minus 4x minus 28. The middle simplifies to x squared plus 3x minus 28. And so here is my equation in standard form. Here we're going to write the quadratic equation in vertex form. Remember that vertex form is y equals a parentheses x minus h squared plus k. My vertex is -2, -3. So when I plug that in, when I substitute that in, that's going to give me x plus 2, since I'm putting in a -2 there, minus 3, since I'm putting in a -3. I still need to figure out what a is in this equation, if it's 1 or if it's another number. So I take my other point, or another point that's on the graph. So here, that other point happens to be -3, -2. -2 is my y. -3 is my x. And I solve for it. So here I get -2 is equal to a, and then this would be 1 squared, -1 squared, minus 3. -2 equals, -1 squared is 1, so 1a minus 3. Add 3 on both sides. This gives me 1 equals 1a, so a is equal to 1. Okay, so now that I know that I can rewrite my vertex form, so y equals, the only thing I need to put in is the 1, x plus 2 squared minus 3. Again, I know that I don't necessarily need to write the 1. And so when I write this, I can just write as x plus 2 squared minus 3. Okay, so looking at this one, we're going to write it in standard form. Again, this time I'm pulling the points out. My solutions here are negative 2 and 2. And another point on this graph is 3, 5. So again, when I write this, I'm writing it in root form, so that's that y equals a x minus r1 x minus r2, using the factors. My solutions were negative 2 and 2, so when I write that, remember that it's the opposite. So for negative 2, it'll be x plus 2. For positive 2, it'll be x minus 2. Remember that I still need to solve for a, so I'm going to plug in my other point. So in this case, 3, 5. 5 is the y. 3 is the x. I get 5 equals a times 5 times 1. So that's 5 equals 5a. So a is equal to 1. So I know that a is 1 here, so when I rewrite it, it's going to be y is equal to 1 times x plus 2, x minus 2. I FOIL here, I'm going to get x squared minus, or plus 2x, minus 2x, minus 4. The middle terms cancel, so you get y is equal to x squared minus 4. Last one, we're going to write this in vertex form. So my vertex is negative 4, negative 4. My other point that I'm going to use is 0, 12. Again, in vertex form, this is going to be y equals a x minus h squared plus k. Okay, we're going to put our vertex in, so this is going to be y is equal to a x plus 4, since it's negative 4 squared, minus 4. I put in my point, which is 0, 12, so the y is 12. X is 0. Alright, this gives me 12 is equal to 0 plus 4 is 4, and 4 squared is 16. So that'll give me 16a minus 4. I add 4 on both sides. This gives me 16 equals to 16a, so a is equal to 1. Now, and all of our examples, a was equal to 1. You still need to check because all of our quadratics are not the same. So this would be 1 times x plus 4 squared minus 4, or just y equals x plus 4 squared minus 4 in vertex form. You could always change this to standard form if needed, which in some cases we would want to do this. This is how we write quadratic equations in vertex and in standard form.